Welcome to class of physics. This is sixth lecture. In previous lecture we had derived an expression for final velocities, that is the velocity after collision in laboratory frame of reference, so that is for elastic collisions. Now I am going to derive an expression for the velocity after the elastic collision in center of mass frame of reference. Okay, so see the derivation. Okay, so this is the derivation. Take screenshot. Okay, let's start the derivation. So elastic collision in center of mass frame of reference. Okay, here consider a particle of mass m1 moving with velocity u1 in laboratory frame and let it suffer a perfectly elastic collision with a particle of mass m2 at rest. Okay, here also two particles are there. Initially we are considering those two particles in laboratory frame of reference. So one particle of mass m1 moving with velocity u1 and another particle of mass m2 is at rest. Okay, the velocity of center of mass of two systems or two particles relative to the laboratory frame is given by v center of mass equal to m1 u1 plus m2 u2 by m1 plus m2. Okay, so that is the velocity in center of mass frame can be written as summation of mi pi divided by summation of mi. Here two particles are there, for that I equal to 1 to 2. When you substitute I equal to 1 to 2, then you will get the expression center of mass. Okay, m1 u1 plus m2 u2 by m1 plus m2. Okay, here initially we assume that the mass m2 to be initially at rest. Okay, so this is our assumptions, so that u2 is 0, then when u2 is 0, this term becomes 0. For that, velocity of center of mass now it becomes m1 u1 divided by m1 plus m2. Okay, and if center of mass and u1 have the same direction, because here u1 and center of mass both are having same signs. Okay, these are the velocities. When both velocities are having same sign, then that indicates both are in the same directions. Okay, so this all explanation is about laboratory frame of reference. Initially we are considering laboratory frame of reference. Now we are going to consider that is in center of mass frame of reference. After that we are going to compare both laboratory frame and center of mass frame by Galilean transformation equations. Okay, now let u1 prime and u2 prime be the initial velocities of the particle of mass m1 and m2 before the collision in center of mass frame. Okay, so initial velocities in center of mass frame is given by primes. This u dash is there na? So these two indicates it is in center of mass frame of reference, but in case of laboratory frame of reference it is simply u1 and u2. Then according to Galilean transformation equations, u1 prime can be written as u1 prime equal to u1 minus p center of mass. Okay, u1 minus center of u1 is what? It is the velocity of first object in laboratory frame of reference, that is before the collision, and p center of mass indicates this is the velocity of center of mass of two objects in laboratory frame of reference. Okay, so then we know already the value of p center of mass, velocity of center of mass, this one. Okay, now substitute this equation in this one, then we will get u1 prime. Okay, so that when you substitute u1 prime, okay, what is u1 prime? u1 prime equal to u1 minus of v center of mass. What is v center of mass? It is m1 u1 divided by m1 plus m2. From these two terms, u1 is common. When you take u1 common, so then it becomes 1 minus of m1 by m1 plus m2. How it becomes? See here, u1 common into the bracket 1 minus m1 by m1 plus m2. Okay, so here 1 minus m1 by m1 plus m2 is there. Take LCM. Here it becomes m1 plus m2. Then this one can be simplified as m1 plus m2 minus of m1 divided by m1 plus m2. Okay, so this plus m1 and this minus m1, so cancel each other, then it becomes m2 by m1 plus m2. Okay, this is m2. For that, what is u1 prime now? u1 prime equal to m2 u1 by m1 plus m2. Next, similarly, we have to write the equation for u2 prime. Okay. Again, what is u2 prime? u2 prime equal to u2 minus v center of mass, but the initial assumption is the second object is at rest in laboratory frame of reference, so that is u2 is 0. For that it becomes minus of v center of mass. Okay, so minus of v center of mass. What is center of mass equation? So it is m1 u1 by m1 plus m2, cause this equation 2. Now we get the initial velocities, that is the before the collision, the velocities in center of mass frame of reference is u1 prime and u2 prime. Okay, so now we get the equations of center of mass as well as the velocities before collision in laboratory frame in center of mass frame of reference of first object and the second object. Okay, now this is a kind of elastic collision. For that, here two quantities are conserved, one is momentum and the one is kinetic energy. Now we have to write the equation for these two, that is one is for momentum and the one is for kinetic energy. Then again the same process of simplifications. And then here u1 prime minus u2 prime equal to u1 minus u2. Okay, so when you subtract these two velocities u1 and u2, that will gives the relative velocity. Okay, the relative velocity in laboratory frame of reference as well as the relative velocity in center of mass frame of reference before the collision is equal to, that is the same quantity, that means both are equal. Okay, the relative velocity between two particles in laboratory frame and center of mass frame is same. Okay. So then v1 prime and v2 prime be the final velocities of the particles of mass m1 and m2 after the collision in center of mass frame of reference. Okay. So here prime indicates those velocities in center of mass frame of reference. Okay. So already we written the value for the velocities before collision in center of mass frame of reference. Okay, equation 192. Now v1 prime and v2 prime are the velocities after the collision in center of mass frame of reference. That is what we have to find out. Okay, our aim is to find the equation of v1 prime and v2 prime in terms of all known quantities. Okay, here v1 minus vcm is equal to v2 minus vcm. v1 v2 are the velocities after collision in laboratory frame of reference. So this is also we don't know. For that we have to modify these two equations in terms of known quantity. For that we are using two laws, one is momentum conservation and the one is kinetic energy conservations. Okay, so v1 and v2 are the final velocities of mass m1 m2 in laboratory frame. In center of mass frame, the center of mass is always at rest. Already in previous class I explained this one, how the center of mass is 0 in center of mass frame of reference, because the center of mass frame of reference is always rigidly fixed to the center of mass. Whatever the moment is there, so that is also along with the frame of reference. For that, the velocity of center of mass in center of mass frame of reference is 0. Okay, so and then for this condition, the linear momentum before and after collision is not only conserved, so those two are equal to 0 also. So now the momentum before collision and the momentum after collisions, we have to write the expressions. So those are conserved as well as equal to 0. Okay, momentum before collision means here before collision the mass of the first object is m1 and the velocity of the first object is what? It is u1 prime. Okay, in center of mass frame of reference. Okay, so that the momentum before collision of first object is m1 u1 prime plus the momentum of second object before collision is its mass and its velocity u2 prime. Okay, so this u2 prime is not equal to 0 because u2 is 0 in laboratory frame of reference, but in center of mass frame of reference it has certain velocity, it is u2 prime. So that the total momentum before collision is m1 u1 prime plus m2 u2 prime, so that is equal to 0. Okay, similarly the momentum after collision, the mass m1 will have the velocity v1 prime and the mass m2 will have the velocity v2 prime, so that is equal to 0. So that is the equation m1 v1 prime plus m2 v2 prime is equal to 0. Okay, so these two are for the momentum equations. And similarly the kinetic energy is also conserved in case of elastic collision. For that we have to write the equation for kinetic energy. Before that, modify these two equations. Okay, so that means we have to write the value of u1 prime and v1 prime. Okay, so that to write u1 prime value, bring this quantity into left hand side. When you bring this into left hand side, this becomes minus of m2 u1 prime, and now this is multiple of u1 prime, for that it becomes divided by m1. Okay. Similarly for v1 prime is equal to minus of m2 v2 prime divided by m1. Okay. So those two are the equation number 3 and equation number 4. These two are written by using these two equations. Okay. Then here negative sign is there. Okay. This negative sign indicates u1 prime and u2 prime both are in opposite directions, and v1 prime and v2 prime are also in opposite direction. That negative sign, if it is positive, means both are in same direction. If those two are in opposite direction, negative means those are in opposite direction. For that v1 and v2 primes are along the same straight line but in opposite direction. Okay. As collision is elastic, the kinetic energy is also constant. Now I have to consider the kinetic energy equation. Yeah. What is kinetic energy equation? It is 1 by 2 mv square. Okay. So kinetic energy is 1 by 2 mv square. Okay. Mass into velocity square. Now in center of mass frame of reference, these velocities are represented by primes or dash. Okay. So now according to conservation law, the kinetic energy before collision is equal to kinetic energy after collisions. Okay. First we have to write the kinetic energy before collision. So this is the kinetic energy before collisions. 1 by 2 m1 u1 prime square plus 1 by 2 m2 u2 prime square is equal to the kinetic energy after collision is the kinetic energy of mass m1 and the kinetic energy of mass m2. These two add together. Then we will get the kinetic energy equation. And here u1 prime square is there and here v1 prime square is there. We already know the u1 prime value. u1 prime value is here. Okay. So this is u1 prime value and this is v1 prime value. Substitute these two equations in this equation. Okay. Equation number 5. When you substitute this one, here u1 prime is what? It is minus of m2 by m1 u2 prime. When you square this, it becomes m2 by m1 u2 prime square. Okay. So this is square and this is also square. Minus of square is plus. For that simply we are going to substitute in case of u1 prime square as m2 square by m1 square into u2 prime square. Okay. So this one, and similarly here it is as it is, u2 prime square is as it is, and here v1 prime square is, this is also replacing by the value of minus of m2 by m1 v2 prime and square that one, then it becomes m2 square by m1 square into v2 prime square. Okay. And this second term is as it is. Okay. Now from these two terms u2 prime square is common. Take this u2 prime square common, then the remaining is m2 square by 2m1. How it comes? Here in this term m1 is there, here divided by m1 square is there, so it get cancelled. The remaining is only 1 by m1. Okay. And here 2 is there, so that it becomes 1 by 2m. Okay. 1 by 2m, and then here it is m2 square. For that total it becomes m2 square by 2m1 plus from this term the remaining is only 1 by 2 m2, that is equal to, and from these two terms v2 prime square is common, take it is common, and here also same. Okay. m1 get cancelled, the remaining is 1 by 2 m1, so that total it is m2 square by 2 m1 plus from this term 1 by 2 m2 is remains. Then see here from LHS and RHS, this second multiple is same. Here m2 square by 2 m1 plus 1 by 2 m2 is there, and here also the same term is there. For that these two get cancelled, the remaining is what? u2 prime square is equal to v2 prime square. Now take the square root, then it becomes u2 prime equal to v2 prime. Okay. So that means our required condition is what? Our required aim is we have to find the velocity after the collision in center of mass frame of reference, that is v2 prime. So that is equal to u2 prime. This is the velocity after the collision in center of mass frame of reference, that is same as the velocity of the second object. Okay. Similarly the v1 is also becomes v1 prime is also u1 prime. Okay. Yes. So totally v2 prime is equal to u2 prime and v1 prime equal to u1 prime. Okay, so these two are the velocities after the collision in center of mass frame of reference. Okay, so for this we'll complete the class, and in next class I am going to derive again the same expression for velocities after the collision, but the condition is in that case we are going to deal with inelastic collisions. Okay, again inelastic collision in laboratory frame of reference as well as in center of mass frame of reference. Okay, thank you.